In the late 1980s, across Midwestern hardware stores and tractor dealerships, a specific mechanical sound began to die. The Kohler K-Series, the heavy cast-iron engine that powered American garden tractors for 3 decades, was quietly being phased out. Introduced in 1952, this single-cylinder block of solid iron had been the undisputed heartbeat of heavy-duty John Deere, Cub Cadet, and wheel-horse machines. But by the 1990s, the cast-iron era had collapsed. Kohler was forced to pivot to lighter aluminum blocks and overhead valves just to survive the changing aisles of big-box discount stores. Dealership mechanics lost the rebuildable blocks they had serviced for generations. Suburban homeowners and rural farmers traded weekend repairs for seasonal replacement. The paradox is that the K-Series did not fail because it was weak. It failed because it was too durable, too heavy, and too expensive for a market that suddenly demanded cheap aluminum and throwaway convenience. But the real story of Kohler Engines is not just the story of a cast iron block that became obsolete. It is the story of how America powered its heaviest work and what happened when that kind of durability became too expensive to keep. Every week, we document the forgotten American engines, factories, and industrial names that once defined what mechanical power sounded like, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, in rural Wisconsin in 1920. The story of the Kohler engine does not begin under the hood of a garden tractor. It begins in the dark. In 1920, much of rural America was completely cut off from the electrical grid. Power stopped at the city limits. If a Midwestern farmer wanted electric light in a barn or a motorized pump to pull water from a well, they had to generate the current themselves. The Kohler Company, already a massive industrial force in Wisconsin, thanks to its mastery of cast iron plumbing fixtures and foundries, saw an open market. They introduced the Kohler Automatic Power and Light. It was a 1,500-watt generator powered by a 4-cylinder gasoline engine. A generator engine, an engine used specifically to turn a generator head and produce electricity, had to operate under fundamentally different rules than a vehicle engine. It did not have the luxury of coasting. It had to run at a constant speed, under a constant thermal load, often left alone in a dusty farm shed for hours or days at a time. The Kohler Automatic featured a breakthrough design. It started automatically when a farmer flipped a light switch inside the house, and it shut down when the last switch was turned off. To survive this kind of unmonitored labor, the engine had to be overbuilt. Kohler poured the engine blocks using the same heavy, durable cast iron they used in their foundry lines. It was a massive, heavy piece of equipment, but it proved something vital to the American market. Kohler knew how to pour iron that would not warp, crack, or fail under heat. For the next 3 decades, Kohler engines were primarily found in the background of American industry. They powered remote outposts, construction equipment, and rural generators. But after the end of the Second World War, the American landscape physically changed, and the engine market fractured into 2 distinct paths. The late 1940s and early 1950s saw the explosion of the American suburb. Millions of veterans returned home, utilized the GI Bill, and moved into tract housing with large lawns. This created a massive, sudden demand for mechanized yard tools. Companies like Briggs & Stratton and Clinton Engines rushed to dominate the lightweight pushmower market, utilizing stamped steel and early aluminum alloys to make cheap, mass-produced power. But there was a gap in the market. America was not only building small suburban lawns, it was building massive estates, expanding rural properties, and pouring thousands of miles of new concrete. A lightweight, inexpensive engine was fine for spinning a blade across a 1/4 acre of flat grass on a Saturday morning. But if a construction crew needed to run a cement mixer for 12 hours a day in the July heat, or if a rural homeowner needed a machine to pull a heavy steel plow through compacted dirt, a lightweight engine would vibrate itself to pieces. America still needed heavy power. It needed industrial-grade iron, scaled down to fit onto mobile equipment. Kohler realized that their foundry experience gave them a massive advantage in the heavy-duty sector. They did not need to compete in the race to the bottom for the cheapest pushmower engine. They could own the premium, heavy work market. In 1952, Kohler officially entered the standalone small engine market with the launch of the K-Series, beginning with the K90. The K-Series was an uncompromising machine. It was a single-cylinder, air-cooled cast iron engine. An air-cooled engine, a design that relies on cooling fins cast directly into the metal and a spinning flywheel fan to shed heat, eliminating the need for a liquid radiator, required thick, high-quality metal to prevent heat distortion. Kohler used a cast iron block. The block is the main engine structure that holds the cylinder and major internal rotating parts. While competitors were experimenting with aluminum to save weight and shipping costs, Kohler stuck to iron. Cast iron is heavy, it is expensive to ship, and it takes longer to machine, but it holds heat evenly and absorbs the brutal vibrations of agricultural work. Furthermore, the K-Series utilized a flathead design. A flathead, an engine design where the valves sit down inside the block itself rather than up in the cylinder head, kept the engine profile compact, simple, and rugged. There were fewer moving parts to break. The center of gravity remained low, which was ideal for equipment that had to operate on steep hillsides or uneven construction sites. When the K-Series arrived in 1952, its early reception was not defined by casual suburban consumers walking into hardware stores. The initial trust was built by fleet managers, construction foremen, and agricultural equipment engineers. Available records and surviving trade literature from the 1950s indicate that Kohler engines were heavily specified for portable pumps, industrial hoists, and heavy-duty tillers. The engine was expensive, but it offered something a cheap aluminum block could not. It was fully rebuildable. In the mechanical culture of the 1950s, an engine was not a throwaway item. If a Kohler K-Series engine wore out its cylinder wall after thousands of hours of dragging a plow, the owner did not throw the engine in a scrap heap. They unbolted the block, took it down to a local machine shop, and had it put through an overhaul, a major service process where an engine is taken apart, inspected, bored out to a slightly larger diameter, and rebuilt with oversized internal parts to factory operating standards. Because the block was made of thick cast iron, it could be rebuilt multiple times. It was an intergenerational purchase. By the end of the 1950s, the Kohler name had become synonymous with heavy iron. The factory lines in Wisconsin were expanding, and the casting foundries were pouring thousands of single-cylinder blocks. They had established a reputation for industrial survival. The foundation was poured in iron, but the machine was about to find its true testing ground not on the factory floor, but in the American suburbs. By the early 1960s, the American landscape was shifting again, and the Kohler K-Series found itself perfectly positioned for a new kind of machine. The American lawn was growing. Families were migrating to the outer edges of suburbs, buying multi-acre plots and establishing small hobby farms. For this new scale of property, a standard push mower was no longer enough, but a full-sized agricultural farm tractor was entirely too big. The gap in the market was filled by a new mechanical category, the American garden tractor. It is vital to understand the difference between a riding lawn mower and a garden tractor. A riding lawn mower was a lightweight, stamped steel frame with a cutting deck, designed only to spin a blade over grass. A garden tractor was built like a scaled-down piece of heavy farm machinery. It had a heavy steel frame, a cast-iron transaxle, and agricultural tires. It was designed to do ground-engaging work, pulling a moldboard plow through clay, turning a heavy tiller, pushing a snow blade, and hauling loaded steel carts. To do that work, the garden tractor needed an engine that did not just spin fast. It needed an engine that could pull hard all day without overheating. In 1961, International Harvester, the massive industrial giant that built full-size farm tractors and heavy trucks, decided to enter the residential market with a garden tractor called the Cub Cadet. When their engineers looked for a power plant, they did not choose a cheap, lightweight aluminum engine. They needed a motor that matched their heavy-duty agricultural reputation. They chose the Kohler K-Series, outfitting the original Cub Cadet with a 7-horsepower Kohler K-161. The partnership was an immediate success, and the rest of the industry quickly fell in line. When John Deere introduced its legendary 112 and later the 140 series tractors, they relied heavily on Kohler power. Brands like Wheelhorse, Gravely, and Boland's adopted the K-Series for their premium lines. The Kohler cast-iron single-cylinder engine became the de facto standard for the heavy-duty American yard. What made the K-Series so dominant in this specific role was its physical geometry and its relationship to torque. Torque is twisting force, felt mechanically as the pulling strength of an engine. It contrasts with horsepower, which is a measurement of how quickly an engine can do work. A cheaply built aluminum engine might advertise high horsepower by spinning very fast, but if you dropped a heavy plow into compacted Midwestern dirt, a fast-spinning, low-torque engine would bog down, lose momentum, and stall. The Kohler K-Series solved this through sheer mass. Inside the cast-iron block, the main engine structure that holds the moving parts, sat a massive, heavy crankshaft. The crankshaft is the rotating steel shaft that turns the up and down motion of the piston into rotational power. Attached to one end of this crankshaft was a massive cast-iron flywheel. This heavy rotating mass acted as a kinetic energy battery. When a Cub Cadet hit a thick root, a hidden rock, or a dense patch of earth, the heavy flywheel momentum kept the piston, the moving metal plug inside the cylinder that is pushed down by combustion pressure, traveling smoothly. The engine did not stall. Instead, it produced a distinct, rhythmic, unstoppable thumping sound. It simply forced the machine forward through brute mechanical leverage. This steady pulling power was expertly managed by the engine's fuel and control systems. The K-Series utilized a simple, easily adjustable carburetor, a mechanical device that mixes liquid gasoline with air before the mixture enters the engine to be burned. But the true secret to its steady power under load was its mechanical governor. A governor is an internal linkage connected to the spinning gears inside the engine that automatically opens or closes the carburetor's throttle plate to maintain a constant speed. In an American driveway in the middle of January, this meant a homeowner could set the throttle lever to maximum, engage a heavy two-stage snowblower attachment, and plunge the tractor into 2 feet of dense, wet, packed snow. As the snow loaded down the machine and the engine's internal speed began to drop, the mechanical governor would instantly sense the change in rotational speed. Without the operator doing a thing, the governor would rip the carburetor throttle wide open, dumping more fuel and air into the combustion chamber. The Kohler would bark loudly. A puff of black smoke might exit the exhaust, but the engine would not stall. The machine kept moving. This level of relentless reliability was matched by its serviceability. Because the K-Series used a thick cast-iron block, it was a generational investment. If a farmer or landscaper ran the engine for thousands of hours and finally wore down the internal metal, they did not throw the engine away. They unbolted the motor and took it to a local machine shop. A machinist would measure the bore, the internal diameter of the cylinder in the stroke, the total distance the piston travels up and down. Using precision cutting tools, the machinist would bore out the cast-iron cylinder walls to a slightly larger diameter, order an oversized piston and a new connecting rod, the part that links the piston to the crankshaft, directly from the Kohler parts catalog, and rebuild the engine. The block survived. The machine went back to work. This entire ecosystem required a specific kind of distribution. You did not buy a Kohler-powered John Deere or Wheelhorse at a discount department store. You bought it at an authorized agricultural implement dealer. These dealerships had dedicated parts counters. They had factory-trained mechanics. If a component failed, a mechanic opened a thick, oil-stained paper service manual, found the exact exploded diagram of the Kohler cylinder head, the upper part of the engine that seals the cylinder and contains the combustion passages, and ordered the exact replacement gasket. The K-Series had crossed over from rural industrial sites to become the undisputed king of suburban mechanical pride. Kohler had not just built a motor, they had built an entire mechanical standard that defined American yard work. But dominating the heavy-duty market at the height of the cast-iron era would soon mean facing a new kind of war. By the 1970s, the Kohler K-Series was no longer just a product line. It was an industrial empire hidden in plain sight across American properties. As suburban plots expanded into multi-acre hobby farms and rural properties required heavy continuous maintenance, the garden tractor market reached its absolute zenith. Kohler was the undisputed king of that hill. At the center of this dominance were specific engine models that became legends in the repair community. The K301, rated at 12 horsepower, the K321, 14 horsepower, and eventually the towering K341. The K341 was a 16 horsepower motor, which is a massive amount of internal displacement to put into a single-cylinder configuration. It contains so much reciprocating mass and raw mechanical torque that mechanics affectionately, and sometimes frustratingly, called it the shaker. It vibrated with a heavy rhythmic cadence that could be felt straight through the steel footrests of a tractor and up into the steering wheel. But that vibration was the unavoidable byproduct of an engine that simply refused to stall under a heavy load. During this era, if an American consumer walked into an agricultural implement dealer to buy a premium heavy-duty machine, they were almost guaranteed to walk out with a Kohler block. John Deere relied heavily on the K-Series for their legendary 200 and 300 series garden tractors. Machines like the iconic 314 and 316, which are still considered by many collectors today to be among the finest heavy-duty yard equipment ever built. International Harvester bolted the Kohler flathead inside their famous Cub Cadet Quiet Line series. Wheelhorse, Gravely, Ariens, and Jacobson all depended on Kohler's cast-iron singles to give their flagship models undisputed mechanical credibility. But the glory of the K-Series extended far beyond the residential lawn. Because the engine was overbuilt, it was drafted into the most punishing industrial environments in America. If you walked onto a highway construction site in 1975, you would hear the steady, deafening thud of a Kohler engine powering a Lincoln Electric portable welder. If a contractor was laying underground pipe in a new suburban subdivision, the Ditch Witch trencher tearing through the compacted clay was likely powered by a K-Series block. Golf courses relied on them for heavy turf maintenance equipment. Rural fire departments relied on them to spin emergency water pumps. Starting a K-Series was a deliberate mechanical ritual. A user had to manually set the choke, adjust the throttle lever, and turn the key. The engine would crank slowly, fighting its own immense compression, before firing to life with a puff of rich exhaust and settling into a slow, heavy idle. It was a sound that told the neighborhood that serious work was about to begin. This scale of dominance created an entire ecosystem of American labor. The Kohler foundries in Wisconsin were running at full capacity, pouring thousands of cast-iron blocks, machining them to exacting tolerances, and shipping them out to assembly plants across the Midwest. But the true strength of the empire lived in the American dealership network. In the 1970s, you did not buy a 14-horsepower garden tractor in a cardboard box from a big box retail store. You bought it from a local, independent agricultural dealer. These dealers did not just sell machines, they serviced them. Behind the showroom was a service bay smelling of gear oil, degreaser, and unburnt gasoline. Behind the parts counter were rows of metal bins filled with Kohler factory parts. If an engine began to lose compression after 10 years of hard labor, the mechanic did not tell the customer to throw the machine away. They pulled down a thick, oil-stained paper service manual, looked up the exact torque specifications, ordered a factory piston ring set, and put the machine back to work. In an America where an engine could decide whether a field was cut, a truck made its delivery, a boat left the dock, a generator carried a hospital through a storm, or a tractor pulled a plow through spring clay, power was not an abstraction. It was iron, fuel, labor, heat, sound, repair, and trust. Kohler had conquered the factory floor and the suburban driveway, but the engine's ultimate test of strength would come from a uniquely American motorsport that pushed the cast iron block far beyond its engineering limits. By the late 1970s, the K-Series had become the undisputed heavyweight champion of a uniquely American motorsport, garden tractor pulling. At county fairs across the Midwest, farmers and mechanics scaled down the massive diesel tractor pulls into a localized weekend competition. The premise was brutal. A heavily modified garden tractor was hitched to a mechanical sled. As the tractor pulled the sled down a 300-foot dirt track, a heavy weight box on the sled mechanically transferred forward, driving a steel friction pan down into the dirt and exponentially increasing the drag. To win, an engine had to operate under maximum load at full throttle while essentially chained to a wall. Competitors quickly realized that cheap aluminum engine blocks would shatter under this kind of stress. They needed thick iron walls that would not flex, warp, or crack when subjected to extreme heat and cylinder pressure. The Kohler K-Series became the only serious option. Builders took the K301 and K321 blocks, removed the factory governor, the internal mechanical linkage that safely limited engine speed to 3,600 RPM, and pushed the motors into violent territory. Running on high-octane racing fuel or alcohol, these single-cylinder flatheads were pushed to 6,000 or even 7,000 revolutions per minute. The noise was a deafening, percussive blast that echoed across fairground grandstands. The straight-pipe exhaust glowed orange in the summer night. The vibration was so intense it would routinely snap standard steel mounting bolts. But the cast-iron Kohler blocks held together. This was not just a weekend hobby. It was the ultimate public proof of concept. If a cast-iron flathead could survive a dirt track while turning twice its design speed, it could easily survive 20 years of pushing snow and pulling plows in a suburban driveway. The motorsport cemented Kohler's reputation as an indestructible piece of American equipment. By the early 1980s, the K-Series represented the absolute zenith of the rebuildable small engine. It was an era where the local machine shop, the dealership parts counter, and the thick factory service manual were seen as permanent fixtures of the American ownership experience. The foundries in Wisconsin were a symbol of heavy manufacturing pride. Millions of these cast-iron engines were operating on golf courses, construction sites, farms, and suburban estates, all backed by a massive network of independent dealers who made their living keeping the iron running. The engine had taught America to trust a sound, a weight, and a specific kind of mechanical permanence. The cast-iron empire felt invincible, but the forces that would tear it down were already quietly crossing the ocean and sitting on the shelves of American discount stores. The first crack in the cast-iron empire was not a catastrophic mechanical failure on a Midwestern farm. It was a quiet financial decision made in the brightly lit aisles of an American discount retail store. By the early 1980s, the American lawn and garden market was fundamentally changing. The post-war generation that had happily paid a premium for heavy-duty generational equipment was aging. A new generation of suburban homeowners was moving into developments with smaller, flatter yards. They did not need to pull a heavy steel plow through compacted clay, and they did not want to pay agricultural dealership prices for a machine that would only be used to cut grass on a Saturday morning. This consumer shift gave rise to the big box retail model. Stores like Kmart, Sears, and eventually Home Depot and Lowe's began selling riding mowers directly to the public. To hit the aggressive price points demanded by these massive retailers, manufacturers had to ruthlessly cut weight and manufacturing costs out of the machines. The heavy cast-iron Kohler K-Series was entirely incompatible with this new economic reality. The problem was rooted in the physics of manufacturing. To build a K-Series engine, the Kohler foundries had to pour molten iron into sand molds, let the heavy blocks cool, and then subject them to extensive, time-consuming machining to achieve the necessary internal tolerances. Cast iron was heavy to move around a factory floor and extremely expensive to ship across the country on freight trucks. Competitors had found a cheaper way: aluminum. Advances in metallurgy allowed rival engine companies to use high-pressure die casting to mass-produce aluminum engine blocks, engine structures made from lightweight aluminum alloys rather than iron. Aluminum could be injected into molds incredibly fast. It cooled quickly, it was vastly easier and faster to machine, and it drastically reduced the shipping weight of the final tractor. But this shift in materials fundamentally changed the American relationship with repair. When a cast-iron Kohler wore down its cylinder wall, a mechanic bored it out and rebuilt it. When a cheap, sleeveless aluminum engine wore out its cylinder wall, the metal was too soft and the walls were too thin to safely machine. The block was essentially disposable. If an aluminum engine failed, the owner did not take it to a local machine shop to be measured and rebuilt with oversized pistons. They unbolted the entire engine, threw it in the scrap pile, and bought a replacement off a shelf. This was the birth of the American replacement culture, and it began to suffocate the independent dealer network that had been the backbone of Kohler's dominance. Independent agricultural dealers could not compete with the sheer volume and low prices of the big box stores. As consumers migrated toward cheaper throwaway tractors, the local service bays saw fewer rebuilds. The thick, oil-stained paper service manuals began to gather dust on the parts counters. Kohler found themselves caught in a dangerous paradox. They were building a premium, rebuildable engine for a market that increasingly wanted a cheap, disposable one. At the same time, the flathead design itself was coming under pressure from a new wave of imported technology. In the 1980s, Japanese manufacturers, most notably Honda, began aggressively pushing into the American small engine market. They did not use the old flathead architecture. They introduced affordable overhead valve, or OHV engines. An overhead valve engine is a design where the valves are moved out of the engine block and relocated into the cylinder head, directly above the combustion chamber. This layout allows the engine to breathe much better, burn fuel more efficiently, and run significantly cooler. Compared to the heavy, thumping, fuel-thirsty Kohler flatheads, these new OHV aluminum engines felt smoother, quieter, and more modern. Kohler knew they were losing ground in the residential market, but they were not ready to abandon the heavy iron that had built their empire. In 1986, they attempted to modernize their cast iron lineup by introducing the Magnum series. The Magnum was essentially a highly refined evolution of the legendary K-Series block. It retained the indestructible cast iron flathead architecture, but it replaced the old mechanical ignition points with electronic ignition, a system that uses solid-state electronic components to trigger the spark plug, eliminating the need for routine mechanical adjustments. The Magnum was an incredibly tough, reliable engine, and it remained highly respected by industrial users, construction crews, and fleet mechanics who still demanded raw pulling torque. But the Magnum was a defensive move. It was an attempt to buy time. The engine was still brutally heavy. It was still expensive to cast, machine, and ship. It still required a heavy steel tractor frame to support its weight and absorb its vibration. The market for that kind of heavy iron was shrinking every year, pushed out by stamped steel mowers and lightweight aluminum motors that cost half as much to produce. Kohler's defining strength, its unyielding heavy-duty durability, had slowly become a financial trap. The iron block had survived the invasion of cheap aluminum and the shift toward throwaway consumerism, but it was about to face an enemy that could not be defeated by mass, torque, or brand loyalty. By 1990, the American regulatory landscape shifted, fundamentally altering the physics of engine design. For decades, the Environmental Protection Agency, EPA, and the California Air Resources Board, CARB, had focused their emissions rules entirely on highway trucks and passenger cars. Small engines had been completely ignored. But as automotive emissions dropped, regulators realized that a weekend fleet of unregulated garden tractors, portable generators, and lawnmowers was pumping a massive amount of unburnt hydrocarbons into the American atmosphere. The government introduced strict new emission standards for small off-road engines. This was Force 3, regulation, emissions, and certification. And it was a death sentence for the traditional cast iron flathead. To understand why, you have to look inside the combustion chamber, the enclosed space between the top of the piston and the cylinder head where the fuel is actually ignited. In a flathead engine like the Kohler K-Series or the Magnum, the valves sit off to the side of the cylinder, down inside the block. When the spark plug fires, the flame front has to travel across a wide, oddly shaped, horizontal pocket to burn all the fuel. It is an inherently inefficient design. It leaves microscopic pockets of unburnt gasoline, which are then pushed straight out the exhaust, the metal piping that carries waste gases away from the engine. Kohler engineers faced an impossible problem. They could not simply adjust the carburetor on the K-Series or the Magnum to meet these new rules. The architecture was fundamentally limited. To burn cleaner, an engine needs to burn its fuel completely. To burn completely, the engine needs a compact, highly efficient combustion chamber, and it needs to run hotter. The only way to achieve this was to abandon the flathead layout entirely and adopt an overhead valve, or OHV design, where the valves sit directly above the piston. But moving the valves to the cylinder head generates a tremendous amount of concentrated heat. If you try to run an air-cooled cast iron OHV engine at those elevated temperatures, the thick iron retains too much heat. The engine cooks its own oil and destroys itself. The engineering solution was aluminum. Aluminum dissipates heat rapidly. It was the only material that could safely handle the thermal demands of a modern, emissions-compliant OHV engine while remaining light enough to satisfy the demands of the modern consumer market. Kohler knew the heavy iron era was ending. To ensure the survival of the company, they poured their resources into a completely new platform, the Command series. The Kohler Command, introduced in the late 1980s and refined through the 1990s, was a brilliant piece of modern engineering. It was an overhead valve, aluminum block engine. To retain some of their heavy-duty industrial reputation, Kohler utilized cast iron cylinder liners, heavy iron sleeves pressed inside the aluminum block where the piston actually travels, providing durability without the massive weight of a solid iron block. The Command series also featured hydraulic valve lifters, internal components that automatically adjusted the valve train using engine oil pressure, completely eliminating the need for a mechanic to manually adjust the valves with a feeler gauge. The Command engine was a massive commercial success. It was incredibly smooth, it was quiet, it burned clean, and it allowed Kohler to maintain its grip on premium commercial mowing equipment and industrial generators. But while the Kohler brand survived the transition, the old American ecosystem that had supported the K-Series collapsed. The shift to aluminum and OHV fundamentally changed the American repair shop. An aluminum block with an iron sleeve was technically rebuildable, but the economics no longer made sense. By the late 1990s, if a homeowner or landscaper brought a worn-out aluminum engine into a local agricultural dealership, the mechanic at the parts counter would run the math. The cost of labor to tear down a modern overhead valve engine, measure the tolerances, and reassemble its complex multi-part valve train was now higher than the cost of simply unbolting the entire motor and ordering a brand new aluminum replacement block from the factory. The art of the overhaul, the deep internal rebuilding of a machine to give it a second life, was replaced by the business of swapping components. The thick oil-stained service manuals that once told a mechanic exactly how to bore out a cast iron cylinder became obsolete. The local machine shops that used to rely on a steady stream of winter tractor rebuilds lost a critical source of income. The heavy foundries in Wisconsin that had poured thousands of solid iron blocks transitioned their tooling to accommodate lighter alloys and different manufacturing techniques. The machines themselves changed. Because the new engines were so much lighter, the garden tractors they powered no longer needed massive, heavy steel frames to support them or absorb their vibration. The entire outdoor power equipment industry shifted toward cheaper, stamped steel riding mowers designed to last 7 to 10 years, rather than heavy-duty iron tractors designed to last a lifetime. The heavy, rhythmic, unstoppable thud of the K-Series was replaced by the high-pitched, smooth hum of aluminum OHV power. The new engines were objectively better for the environment, cheaper to produce, and easier to live with on a Saturday morning. But they lacked the sheer, brute force kinetic energy that had once pulled heavy plows through Midwestern clay. Kohler had successfully navigated the transition. The company was safe, but the world of heavy iron they had created was gone. The engine still ran. The rules tightened. The aluminum took over. The big box stores won. The rebuild stopped. The factories changed. The badge survived. The heavy iron era was over. Kohler Engines did not go bankrupt. Unlike so many American industrial empires that were sold off, liquidated, stripped for parts by private equity, or completely outsourced, the company successfully adapted to the new world. The Command series and the shift to overhead valve, aluminum block engines secured their future. Today, Kohler remains a massive, global manufacturer of modern, highly efficient power systems. They navigated the emissions regulations, they adjusted to the big box retail reality, and they survived. But the Kohler that survived is a fundamentally different company, building a different kind of machine for a different kind of consumer. The badge remained. The Iron Age did not. However, the legendary K-Series refused to vanish cleanly into the scrapyards. Across the American Midwest, rural Pennsylvania, and the Great Plains, a massive subculture dedicated to vintage heavy-duty power has kept the old iron alive. At county fairgrounds and dirt tracks, you can still hear the deafening rhythmic bark of highly modified K301 and K321 engines competing in garden tractor pulls. Mechanics and farmers still push these single-cylinder flatheads to twice their factory redline, proving weekend after weekend that the heavy cast iron block can withstand internal pressures that would shatter a modern aluminum motor. But the preservation of the K-Series goes far beyond specialized motorsport. In barns, machine sheds, and suburban garages, thousands of 1960s and 1970s Cub Cadets, John Deere 112s, wheel horses, and Graveleys are still doing brutal, ground-engaging work. This survival passes the ultimate test. It is not fueled by simple nostalgia. A homeowner does not keep a 50-year-old, heavily vibrating, fuel-thirsty cast iron tractor running just because it looks classic or reminds them of their childhood. They keep it running because a modern, stamped steel riding mower bought at a discount store will literally bend its frame if asked to pull a loaded steel dump cart through a muddy trench. The K-Series matters today because it is a physical, working critique of the modern American replacement culture. It proves that there was once a time when a machine was purchased not as a consumable good designed to fail in 7 years, but as a multi-generational capital asset. The service network that once supported these engines has transitioned into a decentralized, grassroots shadow network. The independent agricultural dealers that used to stock factory piston rings and thick gasket sets have mostly transitioned to selling sealed, disposable aluminum replacement engines. The thick, oil-stained paper service manuals have been carefully scanned, digitized, and uploaded to vintage tractor forums by dedicated collectors. The simple updraft carburetors are still being rebuilt on wooden workbenches, and the mechanical governors are still being carefully adjusted to hit that perfect 3,600 RPM operating speed. The local machine shops that used to rely on a steady stream of winter engine overhauls now mostly handle custom automotive work, but occasionally a farmer or a restorer will walk through the shop doors carrying a heavy, rusted Kohler K-Series block, dropping it onto the parts counter. They will ask the machinist to bore the cast iron cylinder out 10,000ths of an inch, order an oversized piston, and give the machine another 30 years of life. The enduring legacy of this heavy iron is so strong that it created a surprise footnote in the history of American manufacturing. Long after Kohler officially discontinued the cast iron blocks and moved away from factory support for the old flatheads, an entirely new aftermarket industry sprang up to fill the void. Today, third-party manufacturers and specialized machine shops cast their own heavy-duty connecting rods, forge their own pistons, and machine custom valves specifically to keep the K-Series running. The market still demanded the iron, even after the original factory stopped pouring it. The Kohler K-Series did not just cut grass. It helped build the modern American suburban landscape. It powered the portable generators that kept rural hospitals and farmhouses running through winter storms, the industrial pumps that drained highway construction sites, and the heavy tractors that plowed long winter driveways. It represented an era when American mechanical power was measured by its resistance to failure, when a broken machine was an open invitation to repair it, and when a homeowner's relationship with an engine was a lifelong partnership, measured in decades rather than seasons. America did not stop needing power. It simply decided that true indestructible durability was too heavy, too loud, and too expensive to keep. We traded the ability to rebuild for the convenience of replacement. Somewhere in a Midwestern garage, an old cast-iron Kohler K301 still sits bolted into the heavy steel frame of a faded garden tractor. The cooling fins are packed with decades of dry dirt, the exhaust is heavily rusted, and the mechanical throttle linkage is stiff with age. But underneath the iron cylinder head, the block itself is still perfectly solid, waiting for a key to turn, the heavy flywheel to spin, and a Saturday morning to sound exactly the way it did 50 years ago. See you in the next one.